Hello everyone. Now in this video we will be discussing that how a composite number can be resolved into two factors such that the product of those factors will give us the composite number. What I mean to say is, let's say I'm having a composite number like 6, right? Now its factors are like 1, 2, 3 and 6. If I multiply 1 by 2, I will be getting 2. If I multiply 1 by 3, I will be getting 3. But if I multiply 2 by 3, I will be getting 6. Or if I multiply 1 by 6, I will be getting 6. So what I mean to say is that we have to calculate the number of factors. We have to calculate the number of factors in which the number of factors which when multiplied when multiplied gives us the composite number gives us the composite number, right? So we have to calculate such factors which when multiplied gives us the composite numbers. Now a direct formula for this the direct formula for this comes as to be 1 plus p into 1 plus q into 1 plus r and so on, half, right? Half multiplied by 1 plus p into 1 plus q into 1 plus r and so on for a number x, which is a for a number x which can be expressed this in the form of a to the power p, b to the power q, c to the power r, and x is a perfect square, right? And if x is not a perfect square, if x is not a perfect square, in that case the formula comes as half 1 plus p into 1 plus q into 1 plus r into 1 plus r minus 1, right? Then the formula becomes this. So how could we achieve to this formula? Now that's a different case, but we could understand this formula with the help of some examples. Let's say I'm taking an example of 30 and 900. We all know that 900 is a perfect square. We all know that 900 is a perfect square and 30 is not a perfect square. So let's firstly factorize it into prime factors, 2 to the power 2 into 3 to the power 2 into 5 to the power 2. This is how we can factorize it. 900, because this is how we can factorize 900 into the prime factors 2 to the power 2, 3 to the power 2 and 5 to the power 2, right? Now in the previous video we have studied, or we have just discussed about the fact that how could these factors, or how could the factors of 900 can be expressed in the prime factors, right? And in cumulatively we can express them, or we can multiply the sum of those factors such that we can get all the factors additions, right? Or we can get all the factors individually. So this could be gained as 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 multiplied by 3 to the power 0 plus 3 to the power 1 plus 3 to the power 2 multiplied by 5 to the power 0 plus I to the power 1 plus I to the power 2. Right. Now our work will be, because 900 is a perfect square, so what we should get is, what we should achieve is this type of formula. right? And to get to this formula, we can do, we will be doing multiplication. Now I know that this multiplication will be a very long process, so I will just skip to that part by writing that whole multiplication values. So yeah, we are back with it. Now I've written some values. It at first glance it looks very confusing and very abrupt that what I've written. But if what I've done here is that I've multiplied all these values. I've all these values, multiplied all these values to get this as something, this as something value, right? Now the formula suggests that it is half of the total number of factors. So how could we reach to this? How could we reach to this? If you see or observe carefully, then here 1 which is multiplied by, if this number which is 900 gives us the 900, right? Similarly, when similarly when 2 to the power 0 which is 1, 3 to the power 1 3, and 5 to the power 0 uh it is 1. So the whole number becomes 3. And the second last number is 2 square into 3 to the power 1 into 5 square. That means that means we can say that when the second last number and the first and the second number gets multiplied, again the value comes out to be 900, because we are in the desire of reaching to that formula where the product of any two factors gives us the composite number, right? So when when third number is multiplied by the by the last third last number, then again we will get the values, as the composite number. Okay, so this process continues as by getting first that number of terms. If we would get number of terms, so in the first bracket we are having total 9 terms, in the second bracket we are having total 9 terms, and in the third bracket we are having total 9 terms. So overall we are having 27 terms. That means there must be one factor. There must be one factor in all of these factors which is not getting multiplied by any of the number, and hence it is not giving the composite number, right? So what can I say is that for that number, or for that value, I can for that value I can say that there are 27 terms, and in these 27 terms, one number, because the 27 is an odd number, so there must be one number not which is not getting multiplied to any other number, as the first number is getting multiplied, to the last number. The second number is getting multiplied to the second last number. The third number is getting multiplied to the third last number. Similarly, there must be some number which is not getting multiplied by any of the other number to give the value of a composite number, and that would be the number, the 14th term. How I calculated the 14th term? Subtracted 1. That means the till 13th term from the start and the 13th term from the last will be getting multiplied with each other to give the result of a composite number. Or if we multiply these, the first 13th term and the last and the 13th term from the last, then the answer will be the composite number itself. The only term the only term which is not getting multiplied by any of the other term to give us the product, or to give us the composite number, is the 14th term. Similarly, right? So let's count it. So 9 terms are here, then 10, 11, 12, 13, and 14. So this will be the this will be the term which is not getting multiplied by any of the other terms. so that we could get the composite number. And if you observe clearly, then this is the square root. This is the square root of the number. This is the square root of the number. Some important points that we could take out from this observations is that when the number x is a perfect square, when x is a perfect square, in that case the number of terms would be odd. When x is a perfect square, the number of terms will be odd. Now, what are these number of terms? These number of terms are number of these number of terms are the number of factors. Are the number of factors, right? The simple reason is that when I'm talking about that x is a perfect square, then I'm writing it as a to the power p, b to the power q, and c to the power r. P, q, and r. P, q, and r will be something multiplied by 2, will definitely be something multiplied by 2, because if it is a perfect square, then the 2 has to be get cancelled by the half or the square root of that number. So it will be getting multiplied by 2. That means p, q, and r will be the even values. P, q, and r will be the even values. And we know by the formula, which is 1 plus p into 1 plus q into 1 plus r and so on, is that whenever 1 is added to the even value, it becomes odd. So this becomes odd, and this also becomes odd. And you multiply how many times odd with odd, the answer will always be odd. That shows, that simply shows us that when we take any perfect square, the number of factors will always be an odd value. The number of factors will always be an odd value. This is something which is of most importance, right? Then, if I take any other number which is not a perfect square, let's say I am taking the number 30. And if I expressed 30 as 2 to the power 1 into 3 to the power 1 into 5 to the power 1, then now I'm not writing it again in that form which I've written in the perfect square case. I'm just uh, trying to discuss it with simply by writing it in the form of the formula as 1 plus 1 into 1 plus 1 into 1 plus 1, the number of factors, which gives us 2 into 2 into 2, which is 8. So what can we infer from this? That if if the number is not a perfect square, then if the number is not a perfect square, then the number of factors will be an even number. If the number is not a perfect square, then the number of factors will be an even number. How could we say this? This could be understood simply by taking the example, or by taking this example only, as when we add, when it is not a perfect square, that means either P, either Q or R must be odd. Either P, either Q or either R must be an odd number. And when we add 1 to any odd number, it becomes the even number. An even number, when multiplied by the odd number, gives us the even number. So we can say, that if the number x, if the number x expressing in the form of a to the power p into b to the power q into c to the power r, such that x is not a perfect square, not a perfect not a perfect square, in that case, either P, Q or R must be odd. Either P, Q or R must be odd. Either of them, either of them, either of them or all of them could be odd. And if either of them or all of them are odd, in that case, we can say that they will be multiplied, they will be multiplied, they will be multiplied by an even number, by an even number to get as the number of factors, to get the number of factors as even number, right? So this is another inference which we could draw, and the formula that is to be understood, or that is which we could take, is that if n is a perfect square, if n is a perfect square, then the number of factors such that if those factors are multiplied with each other gives us the composite number r 1 plus p multiplied by 1 plus q multiplied by 1 plus r minus 1. And if n is not a perfect square, if n is not a perfect square, then the number of terms would be half into 1 plus p into 1 plus q into 1 plus r, right? This will tell us, this will tell us that how many pairs, or not pairs, but how many factors are there which when multiplied gives us the composite number back, right? So this is all for today. If you like this video, if you love this video, give a thumbs up, and my name is Prakhar Jain. Thank you.